Okay, so we've talked about chemical formulas and all of that. And so you guys are very familiar with the subscript, and you should be familiar with the subscript, right? Because we know that H2O means that there's 2 hydrogen to 1 oxygen, water, right? And if we're talking about sodium chloride, 1 sodium, 1 chloride. And we know about those charges. We know that water is, what type of bond does water form?
Polar.
Polar, that's good. Polar what? Come on, give me a little bit more. Come on, I'm fishing. Let's go. Polar, are they sharing or are they taking? Are they?
Covalent?
Polar covalent, that's right. So they form a polar covalent bond. And we know that sodium chloride forms what type? I know spring break, it went to your head. You're like, okay, you're gonna dump everything out. You guys left it all in the water, right? You went to Pismo. I saw the pictures.
I'm giving the other students opportunity to talk.
Ionic.
Ionic, that's right. Okay, so we know that there's polar, covalent, and their ionic bonds. So now we need to start learning how to sit there. We're gonna learn how to write them the right way. And then also how to sit there and tell when somebody's talking about sodium chloride, right? NaCl, right? So we need to be able to sit there and distinguish what those chemical formulas are. So we know the names of things. We can tell what they are in the bottom, okay? So let's start off with things that we should know and we should be remembering already. Diatomic, diatomic molecules. Diatomic means what again?
2.
2 atoms, okay? So we know that we have diatomic elements. What are our diatomic elements? Who are? She's like,
Have no fear of ice cold beer.
have no fear of ice cold beer, right? So we have hydrogen, nitrogen. Come on.
What else?
Have no fear. What does fear stand for?
Chlorine.
Fluorine. Okay. Have no fear of
Oxygen.
oxygen.
Iodine.
Iodine.
Oh, iodine.
Yeah.
And
Carbon.
Not carbon.
oh, no,
Chlorine.
boron.
Chlorine. Chlorine,
Chlorine.
yes. Okay, so that's our 7, right? Oh, we've got bromine.
Bromine, yeah.
That'll be our 7. Okay, so we know that we have 7 elements that are going to be diatomic, right? So let's get to that. So these are our 7 diatomic elements. So these guys only exist in their stable form as diatomics. So you'll never see oxygen by itself unless we're just using it as an example, you know, as just O. It's always going to be O2 when oxygen, we're talking about oxygen gas. Okay, you guys get that, right? So when it's in a compound, it doesn't have to be, you know, we don't have H2O2, right? We have H2O. It doesn't have to be diatomic because it's in a compound. Okay, does that make sense? Right. And so we know that we can write all the chemical formulas of these because we know that we're talking about hydrogen gas, we're talking about H2. When we're talking about oxygen gas, we're talking about O2. We're talking about nitrogen gas, we're talking about N, right? Okay, so write the chemical formula for chlorine, argon, bromine, and krypton. Okay, let's see, who's my volunteers? Who am I gonna volunteer? Oh, we're gonna start with Michelle, because I haven't seen Michelle in a while. Been missing you. Hey, Michelle, you start off with chlorine. What is the chemical formula for chlorine?
Ooh. I got all my papers here. Chlorine is What do you mean the formula? Just to
chemical
write it
formula.
out? Like
Yeah.
in
So if
nomenclature?
we're talking about chlorine gas, because chlorine is typically a gas,
So would it be
if we have
CO2?
chlorine gas is going to be C what?
CO2?
That is correct. So that would be the chemical formula. Okay. Argon. Chris,
Oh, my glasses.
argon.
Why didn't know you were gonna pick me? Is it AR?
It's AR, that's right. Okay. Let's see. Wow. Hold on, let's see. Alex, tell me about bromine.
BR.
BR?
Yeah.
You know, did you guys realize that this is an all women's hour?
No.
'Cause we rock.
Representation. That's right. Okay, Krypton. Joanna.
What name did you say?
Krypton, Joanna.
Oh, okay.
KR.
KR. Okay. Simple, right?
Simple.
Okay, so let's make it a little bit harder.
No.
Okay. Let's see. Okay, you guys know the difference between metals and nonmetals, right? So you guys know with ionic compound, oh, we also have metalloids, the thing that's kind of in between both. Okay, so we know that with ionic compounds are composed of metals, typically metals and nonmetals. Okay, so you have your positively charged item, which is going to be your metal, is going to be your nonmetal. It's going to be positively charged. Are you there, Evelyn?
Yes, I'm here.
Who's going to be positive charged? Metals or nonmetals?
It would be. Ooh.
Non-metals?
Not nonmetals.
Metals, because they're on the
Metals.
left. Yeah.
That's right. Remember, metals are going to be positively charged, right? Because
Mhm.
look where they're located. They want to get rid of electrons to be like
Yeah.
noble gases, right? So they're going to be positively charged. And so that means our nonmetals are going to be negatively charged. Okay? Good, bad, ugly?
Great.
Okay. We know that when we're talking about molecules, we typically, let me take a step back. We don't know. We will know. So when we talk about molecules or molecular compounds, they're basically based upon like a binary system, right? Binary meaning two. So since we have something positive and we have something negative, we're going to put our positive thing first, right? And so it usually is based upon pairs. So when we're doing our nomenclature, a lot of our names are going to be two items, right? Well, I'll make it a little more complicated, so it can be more than two items. Okay, so what do I mean by that, right? So when we're talking about metals and nonmetals, sodium chloride, right? Two items, right? Sodium,
Right.
positive, chlorine or chloride, negative. So you'll notice there's going to be a couple of things that you notice about naming in general. One of those things is that we use the word ide, I-D-E, at the end of things, right? Chloride, right? Because it's sodium, it's the sodium ion, and it's the chloride ion, I-D-E. That I-D-E serves two purposes. In the case of the ionic compound, it serves to let us know that it's the negatively charged ion, and it's at the end of the sentence, right? When we're talking about covalently bonded things, it lets us know that we're at the end of the compound itself. Like, for instance, carbon dioxide. So carbon dioxide, IDE, right? So it lets us know that we're at the very end of the sentence. Okay, does that make sense?
Yeah.
Okay, and then we have compounds that have what we call common names or traditional names. Now, you'll see this guy often, H2O. So what is H2O again?
Water.
Water. So we don't call it dihydrogen oxide, we call it water. And that's what it's known as. And so we don't want to sit there and, make it difficult. We want to just call it water. Okay?
Could somebody call it that? They want to be fancy?
Technically they could, but they would get it wrong.
Yeah.
Okay. The other one is ammonia. You guys heard of ammonia before?
Yep.
So, and you want to know the chemical formula for these. These are ones that you should know, right? Right. You should know the chemical formula for water and the chemical formula for ammonia. Okay? I'm going to ask you on a test. So, chemical formula for water is
H2O.
okay. So, first we're going to talk about covalent bonds, right? So when we're talking about covalent bonds or covalent compounds, right? We have a certain way of naming things. We use what we call prefixes, like in the case of carbon dioxide, di meaning 2 oxygens. This lets us know that there are 2 oxygens. So we know that it has 1 carbon and 2 oxygens, carbon dioxide, right? So we have these prefixes, these Greek prefixes. Mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. I'm going to teach you two more. Un deca. Dodeca.
Let me guess, 11, 12.
That's right. Okay. So when we're talking about covalent bonds, we want to sit there and use the prefixes. So if I have NO, I'm going to call that what?
9.
I'm not going to call it 9.
Nitrous.
No, 9
Nitri-
means
Is that
no.
nitric oxide?
Nitrous. Yeah.
So we'd call it
Oxide.
nitrogen oxide.
Yeah.
Or we would call it nitrogen monoxide. If I can spell. Okay.
So either way is fine, or
Either way is fine. Yeah.
okay.
Okay. So if I have, say I have this guy. So if you notice, the very first word is not changed, right? So it's
Right.
just that element. And it's also written in the way that it's written in the way that it's given. And so usually the way it's written is in the order of electronegativity. The one who's the most electronegative gets the IDE at the end. Okay. Usually. Okay. So what about this guy? What would I call that guy?
Carbon oxygen fluoride. I don't difluoride.
That's right.
Okay.
Carbon trioxygen.
Dioxygen. Difluoride.
It wouldn't be trioxide, it would be trioxygen.
Only the I goes at the end.
At the end of the.
At the end.
Okay,
It lets us know that it's the end of the compound.
okay.
Okay. Simple.
Yeah.
Simple.
Okay.
So quick question, Dr. Henry. So we're just basically naming the full name of the first, and then the other ones we're just putting like the number of, like the one, like the carbon, trioxygen. So we're just, the carbon, the first one's also going to be the name, the full name. And then
Yeah.
on the other ones, we're going to name it with, like, if they have a 3 tri, or like if they have a 2, and then the name.
Yep. Yeah. So you use the prefix to let us know how many there are. Now, again, this is only for covalent compounds.
Yeah.
Okay.
Can you
These
give
are
us one
covalent
more?
compounds. Oh yeah, I'll give you a couple more, I promise.
Okay.
Okay. Don't worry, you got about 150 of them in the nomenclature homework.
I know, that was hard, man.
Okay, so here's one, Daisy. So we have dinitrogen, that's a typo. Dinitrogen pentasulfide.
So
Would be into S5.
mhm.
Oh my God, that's a lot. The
Piece of
next
cake.
one. Yeah. It's like there's a lot of big words there.
Dinitrogen pentaoxide.
So that would be into
And
O5.
that is too hard.
Okay, 5. So now you notice with the oxygen, if the root ends with an A, then we drop the A. Or if the root ends with an O, we drop the O. So if that prefix ends with an A, we drop the A. If the prefix ends with an O, we drop the O. Because we don't say monoxide, we say monoxide. We don't say pentoxide, we say pentoxide. Okay. So what about this guy? What is that guy's name?
Would be tetraiodine. Is that how you would do that?
And then nona oxide.
And you said nona, known oxide.
Known oxide. Yeah.
Yes. Okay. Okay, simple.
Piece of cake.
What about this last one?
Phosphorus. What's 5?
Penta.
Pentafluoride,
Pentafluoride.
fluoroxide.
Pentafluoride. Okay. Are you guys good?
Mm-hmm.
Okay, good. Okay, so monoatomic ions. Mono means what again?
1.
One single.
One. So one atom ion. Okay, that's kind of self-explanatory. You guys already know this because we talked about it last week and last week and 2 weeks ago, right? For Kalinga.
3 weeks
Right.
ago. 3 weeks ago.
Okay, so when we talk about the monoatomic ion, it's just one atom and another atom, right? So for instance, we're talking about, let's say, magnesium 2 plus. Is this a cation or is it an anion?
It's a cation.
Cation, because it's
Positive.
Charged.
positive, okay? And then let's say we have the phosphide,
Anion.
Mhm.
anion. So when we put these guys together, how many magnesium ions will I need to balance out how many phosphorus ions?
You need 3, if you made it 3 of them. No.
Okay.
If you made
Mg3.
that 3 and the other one 2.
Okay. Good job. Okay, so this guy would be called
Trimagnesium.
So for ionic compounds, we don't use the Greek prefixes. We
Okay.
just use the names. Okay? So we'll call it magnesium.
Diphosphate.
Nope. You don't
Right.
use the Greek prefixes.
Ah.
Nope.
Ah. Phosphide.
Yes. So we would just call it magnesium phosphide, right? So because these guys are charged, they set the standard of how many there are. So you don't have to tell me how many there are. Does that, do you understand that?
Yeah.
Where things that are covalently bonded, we have to tell you how many there are because there's no, it's not charged. It's everything is being shared in that sense. Do you see the difference? Yes, no, maybe.
Yes.
Yes.
Maybe.
Okay. Okay, so if I have this guy, so sodium ion and so what would be the chemical formula that will form and what would be the name of the compound, of the ionic compound?
You have to have an Na4 to make it.
Okay. Na4,
Uh-huh.
Na4 what?
Carbon.
Oh, I'm sorry. C.
Okay, you gotta finish it, you know? I'm not a mind reader here.
In my brain.
Okay, so what would I name this guy?
Sodium carbon?
Sodium,
Sodium,
carboxyl.
sodium,
Carbide.
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 Okay, so we drop the O in and we put IDE.
Okay.
Okay, kind of like for the phosphorus, right? We drop the ORUS.
Right.
Okay.
Okay.
Are you with me so far?
Yes.
Okay.
So why did the Na become positive 4? Do they just kind of like go down, like cross?
It's not that it becomes a positive 4. It means that you have 4 of them. Each of them are being positive, right? So we know that because sodium, where's sodium on the periodic table? Get my periodic table up. Maybe. Come on. There we go. Okay, where's sodium?
The left.
For 11.
Number 11.
Yeah.
Atomic number 11. Don't tell me the left. You know how to name this. You tell me what period, what group. Don't pretend that you lost everything that you learned.
Period 3, group 1.
Okay, so how far is it from being a noble gas?
1.
1 over.
1, right? So if we lose 1 electron, it's a noble gas. So that's why it's a plus, right?
Okay.
Because it's an ionic bond. It's plus
Okay.
because of that. So these guys, period 1, period 2, we know that all the ones that are in period 1 are going to be +1, except for the hydrogen there, special case. Okay, the ones that are in period 2 are going to be what plus?
2.
Go.
Plus. Period 13,
13.
3.
3 plus.
3 plus.
Not period 13, I'm sorry, group 13. What about group 17?
7.
7.
7.
It's going to be 7 plus?
Sorry,
Is it
6.
really?
No. It's gonna be
Negative.
yeah.
It's going to be negative.
Minus
That's right.
It only needs
-1.
one.
That's right. -1. Don't forget all the stuff that you learned, all the stuff before. Remember, I told you it's all building up. You can't just toss it out the window. You got to keep it up here.
I have
That's
short-term
it.
memory, Dr. Henry.
What was that?
I have short-term memory.
Okay. Okay. You guys get that, right? You see how that works? Okay. So what about, let's say we have nitrogen and calcium. Okay. The charge on calcium.
It would be -4.
Calcium,
-2.
It's positive.
I mean, +2.
+2. Sorry.
Yeah, it's plus
In a carbon.
+2. Calcium. Okay, what about the nitrogen?
-3.
-3. Okay, so when I put these guys together, how many of these
3.
do I need to balance?
3.
3.
3 of the calciums
So I'll need 3 calciums
Calcium
and
and
2 nitrogen.
and 2 nitrogens. Okay, so it'll be Ca3, and then you said 2 nitrogens, right?
Mhm.
Okay. Now what do we call this?
tri calcium and
And
nitride.
what is the rule? Spank your hand.
Calcium.
Spank your hand now.
Use the Greek.
Nitride.
Calcium nitride.
Yeah,
That's
nitride.
correct.
That's what I said.
Calcium
Nitride.
nitride. Okay, so we want to remember with ionic compounds, if there's plus and minuses involved, then we do not ever, I shouldn't say that. We don't want to use the Greek letters. Okay, no Greek letters, no di, no tri, or no Greek prefixes, not letters, I should say. Okay, so let's do another one. How about, and you'll notice the positive charge comes first. So you always say calcium nitride, right? The negative charge goes at the end and it gets the "ide." Okay, what about aluminum and fluoride?
Aluminum's a
Fluorine.
+3.
Okay, so aluminum would be +3.
And fluorine is a -1.
And fluorine's a -1. Can somebody remind me? Because I'm old. So remind me, why is fluorine a -1?
Because it's further to the right on the table.
It means
It needs a line.
It's a negative charge.
Okay, so you're saying it's here. So
It's
why is
further-
it -1?
needs to lose one.
Needs
So
to
lose one to
gain an
get
electron.
Become a neon.
It doesn't need
Needs
to lose one, or does it need to gain one?
I mean,
Well,
you
Gain one.
Gain.
Yeah, remember we were talking about electrons. It needs to gain 1 electron, and so to be like neon. So that means that when it's stable, it's going to form a negative charge, 1 negative charge. Okay, so then how many of these am I going to need to balance it out? You said 3?
3.
3.
Okay, so then my chemical compound would look like AlF3. Now you'll notice here, are there any charges on there?
No.
there are no charges. So we want to make sure that we don't have any charges, because if you have a charge on it, that means that it's not balanced. That means that it's probably wrong, right? So what would I name this compound?
Aluminum fluoride.
Aluminum fluoride. Yeah, that's right.
So, but the aluminum is a transition metal, is it?
No, aluminum is a post-transitional metal, but it's always gonna be 3. Always.
Okay.
Yeah.
Okay.
And that's where it's located at. When we get down here, these guys, they don't behave that rule. So
Yeah, okay.
you guys hold on for 1 second. I'm gonna give you guys a couple of ones to work on. So, and then I'm gonna
Wait,
see
Dr.
if they
Henry.
have a package on my door. Yes. So let's see. Let's do Li P. We'll do K O, and we'll do, let's go T E A L. Okay, so do these 3 sets. These guys are going together, these guys are going together, and these guys are going.
So for number 1, you guys, would it be Li3P?
Yeah.
Yeah, that's what I got. P.
So
Isn't it LiP3 plus? That's what.
it's
And don't forget to name it.
with P.
Lithium.
Lithium phosphide. Phosphide.
Okay.
So what's the rule on that TE one, Dr. Henry?
Okay, it is a metalloid, right? So it can behave like a metal, or it can behave like a non-metal. Okay, so depending on who it pairs up with, it's going to be how it behaves. So who do you think is going to behave like now?
Like a metal.
It's going to behave, are you sure?
No,
Hold on, let me rethink.
no, it's gonna behave like the other ones because the aluminum's gonna behave like the metal.
That's right.
But how do you change the name of tellurium? Where do you stop the word and put the?
So it would be right after the R. So it would be Telluride. And there's
Okay.
actually a car named Telluride.
I know,
That's
it sounds familiar.
They actually use tellurium in it.
Wow. Pretty expensive.
Actually, it's not that bad. Okay. What about this next one? KO.
Huh? Potassium oxide.
They're already equally balanced, right?
Are they?
No, it's -3 and potassium's -3 charge. And
Potassium is -3?
No.
No, it's
phosphorus.
+1.
1.
Okay.
+1.
It's +1. Okay. And the oxygen?
-2.
-2.
-2. Okay, so then how many am I going to need to balance it?
3.
I'm going to need 3.
Potassiums and 1 oxygen.
So 2 potassiums and 1 oxygen. Okay, so K2O.
Potassium oxide.
Okay, and we would call it potassium oxide.
Oxide.
Okay, and the last one.
It would be aluminum telluride. Aluminum's +3. No, +3.
1 aluminum and 3 tellurium.
I have 2 aluminum and 3 tellurium.
So you said 2 aluminum
Yeah,
Mm-hmm.
and 3 tellurium.
yes.
That is correct. Because we know that this is a -2 charge, and then this guy is going to be
3 plus.
3 plus charge. So that means we'll need 2 of these guys. That's going to add up to 6. And then we'll need 3 of these guys. That'll add up to -6. Okay, piece of cake.
Mhm.
Okay, clear. Okay, so, okay. So are you guys ready for some hard stuff now?
Mhm.
Okay.
No.
Let's see. Let's try one more. We'll try one more of these. Let's see. So we'll use selenium and selenium and rubidium. That's a RB,
Oh, rubidium.
rubidium.
So would it be SERB2?
What is the charge on Se?
-2.
-2. Okay. And you said rubidium would be
Just +1.
+1. Okay, so would it be Se RB2 or would it be RB2 Se? What's the rule?
Oh, yeah, RB2 SE.
There we go. RB2.
Because we need 2 of the S. Yes.
There you go. So 2 rubidiums for, yeah, that is correct. Yes, but you always want to remember the positive charge goes first.
First. Okay.
Okay. And what would be the name?
Rubidium.
Rubidium selenide? Selenide?
Yes, that's right.
Selenium.
Rubidium. Okay. Piece of cake?
Mm-hmm.
Okay. Okay, so now, you know, we've been avoiding these metals for the longest. Now we get to play with it. These transitional metals, I can get them highlighted, and post-transitional metals. Okay, so these metals here, and then sometimes metal. So because those guys can have multiple charges associated with them, right? Meaning that they can have multiple plus charges associated with them. We have to sit there and distinguish between them, right? So for instance, if I have iron, right? Well, iron is kind of a special case. Iron, we could have iron 2. We could have iron 1. We could have iron 4. And rare, iron 3. Or we could have iron 6.
Is that why these metals are not assigned
Yes,
a certain charge for the column? Okay.
that's right. And they behave weirdly under different circumstances. So depending on how you use them and the way that you melt them and the way that you interact with them, it can affect the charge. Okay. So because of that, transitional metals have to be named differently. We have to use are Roman numerals. You guys know what Roman numerals are, right?
Mhm.
Yeah.
I, right? IV. Okay, so we have to use Roman numerals to sit there and name these metals. Okay, so the way that we would call this ion, we would call it iron 6, which is Bi, ion. Okay, this guy would be iron 2, ion. This guy,
Iron 4.
iron 4, ion. Okay, you see the trend? You see how it works? So your transitional metals are like that. Now, there are going to be some exceptions, and I'll talk to you guys about those exceptions later on. Right now, just assume anytime that you have transitional metals, post-transitional metals, or metalloids, the only one that's an exception that you know of is aluminum. Aluminum is always going to be 3. All these other ones, right? It just depends on who they're with and what they're doing, okay? So because of that, we have to pay attention to who they're pairing up with, who their partners are, okay? So, for instance, if I have Fe I3, okay? So what is the ion for iron? And how would I name this compound?
Fe1. Fe1.
Okay, so what is the charge? What would be the charge on Fe? What is the charge on iodine?
Iodine is -1.
So if iodine is -1 and I have 3 of them and I only have 1 Fe, so what must be the charge on that?
You make it a 3.
That's right. So that means that that Fe has to be a 3, right? So it'd be Fe3 plus. So then the way I would name this guy would be iron
3.
iodide. Okay, so those Roman numerals tells us the charge on that ion. Okay, do you guys get that?
Can you go
Mhm.
through that one again? Because
Yeah, sure I can. Okay, let's get rid of this. Okay, so since we have only 1 iron here and we have 3 iodides, what is the charge on the iodide?
-1. So it'd be -3.
So altogether it'll be -3. So the charge on the Fe, that 1 Fe must be what?
+3.
It has to be a +3. Okay. So since it's +3, then we would call this guy iron 3 iodide. Do you guys get that?
Mhm.
Okay, so let's give you a hard one here. We'll stick with iron because you. Okay. Okay, so what must be the charge of this iron? This one right here.
It'd be a +2 for one of them
Is it going to be a +2?
because the oxygen is -2.
So the oxygen is -2, right?
Mhm.
So if we have each of those are -2, we have 3 of them, right?
So
Is
it's
that right?
+6. No,
So
because then
this-
the Fe's would have to be 3s because there's 2 of them, right? Is that
There we
right?
go. That is correct. The Fe's would have to be a +3. That's right. Okay, So then we have 2 of those, so each of those would have to be +3. So then if I name this compound,
Be iron 6.
is it iron 6? Because you're talking about 1 iron.
1
What
iron.
is the charge on that iron? On a
3.
single iron?
3.
3. So then it would be iron 3. So remember, it's just that charge for a single ion.
It's only the charge. It's not the amount of the numbers of them.
That's right.
Okay.
Okay. Iron 3 oxide. Are you guys there?
Yes.
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 Got it. Is
Got
this on the lab? Right?
This is on the lab. Yes, this is on the lab. Okay.
Okay.
Okay, so let's try one more for the road. Let's do it.
Would be copper 2. Sulfide, the sulfur was -2.
Okay, so the sulfur is a -2.
Mm-hmm. So it'd be copper would end up being a +2 because there's 2 of them, but there's just, each one would be a +1.
Okay, so Cu plus. Okay, so then what would I name this compound?
Copper sulfide. Because each one of the coppers are 1.
I know, but you want to still give it, because if you just say copper sulfide, is that copper 1 sulfide? Is that copper 3 sulfide? Is that?
Okay.
So you
Okay.
have to tell me.
You have to specify copper
Yes.
1 sulfide then.
Okay. It's kind of like we were talking about Diana. Diana, right? But I have 4 Dianas in my class. Which one am I talking about? Right? Is it Torres? Is it Montoya? Is it Pico? Right? No. Is it Pico? I know you're there, Diana. Okay, so it just depends, right? So if you don't let me know which one it is, I don't know, right?
Right.
Okay, so it's important to let me know. Okay, now there are going to be exceptions. I'm going to say that again. There are going to be exceptions, and I will let you know about those exceptions. But if you're ever in doubt, always use the Roman numeral, okay? Okay, so now when we talk about these guys, we know that we don't need to use the Roman numeral because these guys are always group 1 and group 2. These guys always are going to be the same charge. This guy's always going to be +2. This guy's always going to be +1. Okay? Are you guys with me?
Kind of.
Kind of?
A little
Sort
confusing.
of.
What was that?
It's a little confusing.
It's a little confusing.
I
Okay.
got a little confused with the, you know, how like with the transitional metals,
Yeah.
with the Roman numerals.
Yeah. So always remember the Roman numeral means the charge, right? So in this case, we know that sulfur. So sulfur is always going to be the same. What is the charge on sulfur?
-2.
-2.
-2. So it's always going to be -2. If I have 2 sulfurs, then what must be the charge on each? I mean, if I have 2 coppers, what must be the charge on each of the coppers?
A plus charge.
Just a plus charge, right? +1. So then we know the charge of that copper. So then we call it copper 1 sulfide.
But because you have 2, you wouldn't add the 2?
No, because you look at for
You're just
each
looking
one.
at that one.
That's right. Because like, for instance, when we did barium, let's say we have barium chloride, right? Do we say, oh, this is -2, right? Altogether, there has to be 2 of these to balance this out, right?
Yeah.
But we still call it barium chloride. So we just need to let us know the charge on a single one of them.
Okay.
Do you get that?
I get that part. So all those transitional metals would basically just have one charge, or would they all have different ones as well, like the other ones?
All transitional metals can have multiple charges. So it just depends on who they're pairing up with, right? So all of these guys here, all your transitional metals, transitional metals, all these guys here, and some of these guys here, right? And these guys down here, right? All of these guys, they're gonna have multiple charges associated with them. And so that's why you have to use the Roman numeral to let us know what charge it is.
But aluminum, did you say aluminum does its own thing though? Is that one stay the same all the time?
Aluminum is always gonna be 3. That's an exception.
Okay.
Yeah, but 10 can be 5, it can be 6, it can be 2, it can be 1. So it just depends on who it pairs up with and how you work with it. And that's one of the reasons why like the transitional metals are very difficult, because you know, if you handle them the wrong way, you can end up with something totally different than what you're expecting. And it'll behave different. It'll look a little different. Like for instance, we play with copper, actually. Copper. So if you heat it up to a certain temperature, it loses 1 electron. Heat it up to another temperature, it loses 2 electrons. And if you keep heating it up for a really long time, it'll end up losing 4 electrons, right? So those all are going to behave different. Okay. So let's see. You want to give it another shot? Okay, what about this guy? Okay, what would this guy be?
Where's the zinc?
Oh, right there.
30.
So what's going to be the compound?
Phosphorus is. The P is the -3. Can't find the zinc.
Number
It's
30.
30.
30.
Okay. Oh, there we go. So zinc would have to be a negative charge. Each zinc would be a -1.
Are you sure?
It's a positive charge, so it can balance out phosphorus, right?
Oh, I'm sorry. Yeah, positive.
Okay. So you're saying it'll be each, we have 3 zincs.
So
Each one would be a positive.
Positive, yeah, because phosphorus is negative.
Okay. Okay, so then what would be the name?
Zinc phosphide. Zinc 1 phosphide.
Okay, zinc 1 phosphide. Okay.
I like how I'm understanding this.
Good. I'm liking how you're understanding it as well. Okay. So, feeling pretty confident?
Yes.
Okay, good, good. Let's see, let's give you a hard one now.
Not on those, but okay.
Let's do.
So tungsten would be +6, right?
Are you sure?
Mhm.
I hope so.
What is the charge on oxygen?
-2,
Minus.
-2.
And there's two of them.
So it'd have to be a -4, +4, because there's only one.
So then it would be,
Tungsten 4 oxide.
okay, tungsten 4 oxide. Because we know that oxygen is always going to be a -2 charge. There are two, let's scoot that up. There are two oxygens, so that's a total of -4. So that means there's only one tungsten that has to be a +4. So tungsten 4 oxide. Do you get that?
Yeah.
So we have to pay attention to who the transitional metal is paired up with. That's going to give us its charge. And once we got its charge, then we can sit there and name it correctly. Okay. Okay, so how many of you guys have your polyatomic ion table printed out?
I do. It came with the kit.
I think you gave it to us. Yeah,
I did.
you did. Where is it? Polyatomic ions. Here we go.
Okay. So you want to be familiar with your polyatomic ion. So your polyatomic ion takes characteristics of your covalent bonds, right? So poly means, what does poly mean?
Multiple.
Multiple, right? Multiple polyatomic, multiple atoms, okay? So we have multiple atoms. Let me pull up my polyatomic ion table. That's what I'm talking about. Maybe. Here we go. See it? Sorry. Do you guys see the polyatomic ion table?
Yes.
Okay. So these are your polyatomic ions, right? So you want to be familiar with this. You want to be familiar with the sheet. But the thing that you want to notice is that all of these guys are nonmetals, right? But these nonmetals, they get a charge, right? They're acting covalently, but they also have a charge associated with it. Okay, you drew some of these guys when you were drawing your Lewis dot structures. You guys remember?
Yeah.
Yeah. Okay. So I'm going to talk to you a little bit about them to kind of help you understand how they're organized, how to remember the name and stuff like that. And then we're going to start using them in ionic compounds. Okay. So I'm going to go to the whiteboard. Maybe. Do you all have your? Sorry, running a little sleep right now. I'm working on this grant, so I've gotten very little sleep. Okay, so let's talk. So PO4 3 minus. What does that guy call? You see it on the table?
Phosphate.
Phosphate. Okay, so this guy is called phosphate. Okay, so since this guy's called phosphate, a little bit bigger. Okay. PO3, 3 minus, is called
Phosphite.
phosphite.
We can only see half of your polyatomic ions on your screen. I'm
That's
only
okay.
mentioning that. Oh, okay. I was gonna say because if somebody doesn't have the printout and they're looking at the screen.
Okay. Okay. Well. Okay, so you guys see phosphate, phosphite. You notice that the charge is still the same. What is the difference between our phosphate and our phosphite?
One has 3 and one has 4
Yeah.
The number
For
of
what?
oxygen.
For
oxygens.
oxygens. Okay.
Yeah.
So anytime that you see AT, or I should say most of the time, excuse me. Most of the time when you see ATE, it means that you're working with something that has oxygen in it. These are called oxyanions. Okay. ITE, same thing. The only thing, the difference between the ATE and the ITE, the ATE starts off with a certain number. So in this case, we start off with 4 oxygens. And then we drop down by 1, and that makes it an ITE. If we drop down by another one, say we have PO2, 3 minus, then this guy would be called hypo. Phosphite. Okay. Can you guys see that?
Yeah.
Okay.
What you type?
Okay. And we know that P3 minus is called phosphide. Right? Now you notice the phosphide has a -3 charge, and all of these guys have a minus. So normally our oxy anions, these guys are gonna kind of pair up. Their charge is gonna be associated with the charge of the guy it's paired up with. Okay, usually. There are gonna be some exceptions. Okay, so I have to show you one more. If I have an extra oxygen, this guy is called phosphate. How many of you guys have kids?
Me.
So if we feed your kids a whole bunch of candy, what's gonna happen?
They get all sugared up.
They get all
Hyper.
sugared up. They're gonna get hyper, right? Hyper. So that per kind of stands for hyper. So that lets me know that I have an extra oxygen. Okay. Are you with me?
Yes.
Now you see the
Yes.
trend. You notice that the charge doesn't change. The charge is the same on all of them. The only thing that's different between them is the number of oxygens that they have. Are you with me?
Mhm.
Yes.
Okay. Okay, so now we're going to see. So we have 8. So 8. So light. So Okay. You see my little screen there?
Yes.
Okay, good. Okay, persulfate.
There's 5 of them.
Okay. And so what would be the chemical formula?
S5?
Is it S5?
No, it would be
So for
S2 negative and 5 of them.
S negative?
That's
It's
five
negative.
negative.
It's -2.
Okay, now remember, it has ATE at the end. That tells me what again?
And that means there's 4
4 of what?
Oxygens.
oxygens.
Oxygens. Okay, so
Okay.
we know that if we were talking about sulfate, it would be SO4.
SO4.
Yeah.
Okay. So it's SO5.
SO5.
That's right. And what would be the charge? Because we know that sulfur has what charge?
2 -2.
-2. And so this guy would be SO5. What would be the charge?
2 -2.
-2. Okay, now what about sulfite?
SO3.
SO
Right?
3
3 of them. SO3.
-2.
-2. And then hyposulfite.
Ooh, there's 2 of them, so it would be SO2
S
-2.
That's right. And then sulfide,
5 is 1.
IDE.
It would be just SO and
Would there be an O? Not an 8. There's no 8 at the end. There's no oxygen.
just S.
S.
Yeah.
Then would you put the charge with O2 negative? Okay.
Okay, sample.
Man, I think
Okay,
somebody had way
somewhat.
too much time on their hands when they were learning to do this.
Oh yeah. Well, you should have saw it before they did this. It was a hot mess. They would call, you think I'm kidding. This is Henry's reagent. And then there would be 50 other people calling, no, that's Tom's reagent. No, that's Johnny's reagent. No, this is shoestring. You know, I mean, it was really crazy. So they got together and they said, no, we can't have it this way. So we need a system. That's what is called IUPAC nomenclature. Okay, so let's see. We'll do one more for the road. I'm gonna clear it out. So let's do, I'll put them up and you tell me their names. Okay, the first one.
Bromate.
Are you sure?
Because there's 4 of them.
So this is something that you gotta also kind of learn. So bromate is actually BrO3. So some of them are gonna be start off with less oxygen. They won't always start off with 4 oxygens.
So perbromate?
So the top one would be perbromate. That's right. And you can usually look at the group that they're in and look for something on the Polyatomic Ion Table that'll help you figure that out. Like for instance, perchlorate. See that down here?
Yeah.
Okay. So then this guy would be bromate. And we know that this guy is
Bromide.
bromide. And I can put all the ones in the middle because I know that bromite is going to look like what?
BrO2.
2.
That's
Yeah.
right. And a minus charge.
Yep.
And then hypobromite.
It's
BRO minus.
BRO5 minus.
Hypo, not hyper. Hypo,
BRO.
There's two of them.
BRO.
Or two.
But are you sure?
No.
You said
Yeah.
hypo is
by
two.
itself.
Hypo would be 1, right? Because if bromite was 2,
Oh, okay. So why does it change from this one to the other one? The PO4s.
so under those, so that's actually a very good question. And I've still been trying to figure that one out, but I think it has something to do with the fact that those guys, sulfur and phosphorus, they can use that d orbital, willy-nilly, and they're more apt to use it than the other guys. Like bromate really doesn't want to use it unless it absolutely must, so it'll try not to. So I think that's something to do with it, but I'm not 100% sure.
Okay, but is this the only one that's like that?
Nope, because we have nitrate. Nitrate really screws everything up because it doesn't even have a -3, because you'd assume it'd have a -3 charge. It has a -1 charge, right? And it also starts off with, so bromate, chlorate, phosphate, all of these guys start off at 3.
Okay.
So basically from the highest to the lowest, it goes per, and then 8, ite, hypo, and then ide.
That's right.
Okay.
And then you pay attention, like hypo, ite go together.
Yeah.
Per, 8 go together.
8. Yeah.
Yeah, so I always kind of like using this guy because this guy is easy to find. You can always
Yeah.
find a bromate, and then from there you can figure out everything.
Yeah. If you can find it on here first, then go from there.
Okay, so how do we use this, right? So we're using this the same way. Now, only thing that we're going to be doing differently is that these guys are going to be working as a unit, right? Oh, there's one more thing. I should probably do more, but we'll talk to you about one more right now. Then we'll hit the other one in a minute. So the other one is Nh4 Plus. So this guy is called ammonium. You guys already know about ammonia. This is ammonium. Okay. Now ammonium is a positive polyatomic ion. It's one of the few that are like that. Okay. So let's say I have ammonium and I have, say, just for right now, sulfide coming together. So what would I name this guy and what would the chemical formula look like?
Ammonium 1.
So is ammonium a transitional metal?
Oh.
So we know that ammonium was always going to be a +1 charge. It's never going to change. So since we know that, we don't have to put a Roman numeral.
Oh, okay.
Okay, so then what would I name this? Ammonium. If I put these two together, what would be the compound? What would be the chemical formula? What was that?
Is it?
Ammonium sulfate.
Disulfide.
Ammonium sulfide.
Sulfide.
Remember,
Okay.
we don't ever use dye, right?
Yeah.
Yeah.
When we're talking about ionic compounds,
Okay.
even if they're polyatomic. Okay. Okay, so now what would be the chemical formula?
Nh4S2.
And you said N84.
Nh4S2.
Why would it be 2? Why do you think it's 2? What is the
Because you
charge
have
on
two,
sulfur?
because you have a -2.
I have a -2, but that means it's a -2 charge. So do I need, if I have 2 of it, that means now I have -4. So that's saying you're telling me that I have this many.
Don't
Is that
you
what
have
we have?
It's no, it's just by itself.
So it's going to be alone.
Yeah.
Okay. And then What about the NH4? That's only a plus charge. Is that balanced?
No.
No. So how many do I need to balance it?
Half.
So
Oh,
this is a plus, that's a 2.
you need to have 2 of them.
I need 2 of these, right? So if I have 2 of these, then I would write it as
2
the same
NH.
way. Yeah, NH4 parentheses 2S.
And
Do you see that?
Uh-huh.
Do you see that, Deanna?
yes.
Yeah. So you're right. You were sitting there thinking about it in the right fashion, but in the backwards way, you know. So you always want to sit there and think about it in terms of what do we have, right? So we had a plus. We need 2 of those pluses to balance out that 2 minus. Okay. Are you with me? Everybody's with me so far?
Yes.
Okay.
Yes.
So let's see. We'll see how well you guys do now. So what if I have this guy, aluminum, and
The aluminum iodide.
okay, so we call aluminum iodide. Is it iodide or iodate or
Iodate.
iodate? Okay, it'll be called aluminum iodate. That would be the name. So what would be the chemical formula?
AO3.
Al3IO.
No.
Would
No,
it be AL and then parentheses IO3?
There you go.
Then
IO3. And then how many will I need?
3.
3.
There we go. That will be it. Good job. Virtual high five.
Wouldn't you put the 3 after? No, never mind, you wouldn't. Because the aluminum's got a 3 charge.
That is correct. We know that the aluminum is going to have a 3+ charge. So we're going to need 3 of these guys to
But you
balance it
have
out.
3 of those guys.
What was that?
In the IO, oh, because of the I? Why do you need 3 more of the IO3s?
We'll need 3 total of the IO3s.
But you
Right.
already have 3 of them.
No, I have 3 oxygens. I don't have 3 of them,
Okay.
right? So this means that remember, this represents the whole thing. The whole thing has a single negative charge.
Okay.
Okay?
Mm-hmm.
Does that make sense?
Mm-hmm.
Yes.
Yeah, that was a good question she had though.
No, I know. Because usually that's what we get carried away with. We pay attention to this and we're like, oh, there's 3 of them. No, there's 3 oxygens, but it's a compound. That whole compound has a single negative charge. So we'll need 3 of that compound to balance out that aluminum.
Mhm.
Does that make sense?
Yeah.
Yeah.
Okay. Questions, concerns, catch, credit. Okay. There's one more thing that I want to go over real quick, and it's called hydrates. Hydrates is just basically compounds that have water associated with it to kind of either help it dissolve or help it stabilize. Okay. Now, these hydrates, the way that we would name this, you would keep the same name, aluminum iodate, and then you get a chance to use your Greek prefixes. We would add on to this, and we would say trihydrate, meaning that you have 3 waters attached to it. Okay. You guys see that?
Yeah.
Okay.
Yes.
So if I have this guy, let's say I have Okay, what would be the name of that guy?
Sodium.
Carbon.
CO cobalt. It's cobalt.
No, it's capital C, capital O3.
Carbon monoxide.
Oh,
Carbon.
Nope.
I don't know how to say it.
Let somebody
Carbonate?
say it.
Is it
Carbonate.
carbonate?
Carbonate.
Carbonate? Oh. I was like baking soda.
Sodium carbonate, and what was that?
Non-hydrate.
Nanohydrate.
Nanohydrate. Yes.
Yeah.
Monohydrate.
Nonahydrate.
Yeah.
But it's times that. Is that a times?
Yeah, it's a big O. I mean, a big dot. Yes. So it's kind
Multiplication.
of like times. Yeah. So basically, you're just saying we added a whole bunch of water.
Yeah.
So yeah, usually it's a big,
Yeah, I saw that in the homework. I was like, what?
yeah, big dot. Okay. Okay, questions, concerns, cash, credit.